Imagine a world where machines can learn and adapt just like humans, making decisions based on past experiences and data. This is not a science fiction movie. It's the reality of our data-driven world today, thanks to supervised learning algorithms. Now, what is a supervised learning algorithm? It's a method used to enable machines to categorize or predict outcomes based on input data. It's like teaching a child how to identify animals. You show a picture of a dog and say, "This is a dog," and repeat the process with other animals. Similarly, you train the machine with labeled data, and over time, it learns to identify patterns and make predictions. Output. So how does this work in practice? It all starts with data, specifically labeled data. In our animal example, the labeled data would be the pictures of animals with their names. This is the first step of supervised learning, acquiring and labeling the data. Next, the algorithm processes this labeled data. It identifies patterns and relationships between the input, which is the picture of the animal, and the output, which is the animal's name. This is the learning phase, where the algorithm builds a model based on the patterns it has found. Once the model is built, it's time to test it. The algorithm is given new data without labels and asked to predict the outcomes. If the model correctly identifies a dog as a dog, it's a success. If not, adjustments are made to the model, and the learning phase is repeated until the model is accurate. This is the iterative nature of machine learning. Now, there are several types of supervised learning algorithms, each with its own strengths and applications. Linear regression, for instance, is great for predicting numerical outcomes, like the price of a house based on its features. Decision trees, on the other hand, are fantastic at classification tasks, like determining if an email is spam or not. So what are the key takeaways about supervised learning algorithms? First, they learn from labeled data. It's like teaching a machine with a well-organized textbook. The better and more comprehensive your labeled data, the better the machine can learn. Second, these algorithms are iterative. They continually learn and adjust, improving their models over time. It's a cycle of learning, testing, adjusting, and learning again. Third, there are many types of supervised learning algorithms, each suited to different tasks. Choosing the right one depends on your specific needs and the nature of your data. Finally, supervised learning algorithms are everywhere. They're behind the recommendations you get on streaming platforms, the voice recognition on your smartphone, and even the spam filter in your email. In a world increasingly reliant on data, understanding and leveraging these algorithms is more important than ever. They're not just reshaping industries, they're reshaping the world.